Hold fast! She's breaking apart!
Somewhere off the edge of a well-charted coastline, a survey vessel moves at a deliberate 4 knots, dragging behind it a torpedo-shaped instrument suspended a few dozen meters above the seabed. The people aboard are not looking for anything in particular. They are filling in a blank space on a hydrographic chart, one of thousands of routine passes that make up the unglamorous work of mapping the ocean floor. On a screen in the vessel's dim operations room, a slow, grayscale image builds line by line, painted by sound rather than light. For hours, it shows the expected, a flat plain of sediment, the occasional boulder, the faint ridges left by ancient currents. Then the pattern breaks. A shape resolves out of the noise, too regular to be natural, too large to ignore, and unmarked on every chart the crew has aboard. Someone leans toward the display and says the thing that begins every story, like this one, that isn't supposed to be there. The instinct in that moment is to imagine the extraordinary. A lost city, a wreck no one recorded, something the maps deliberately omitted. But the more interesting and more accurate story is about what that gray smudge actually is, and about the strange, counterintuitive truth at the center of modern oceanography, that the seafloor is not really mapped at all, and that finding something no chart shows is not the exception, but very nearly the rule. To understand why the sonar revealed something absent from every map, you first have to understand how little those maps have ever contained. We tend to assume the world is finished being discovered. The globe on a desk, the satellite imagery on a phone, the seamless blue of the oceans on any digital map, all of it projects a quiet confidence that the surface of the Earth has been accounted for. That confidence is mostly justified for the land. It collapses the moment you go underwater. As of the mid-2020s, only around a quarter of the global seafloor had been mapped in genuine detail, meaning measured directly by ships carrying sonar rather than estimated from a distance. The rest, the great majority of the planet's solid surface, exists on our charts only as a blurry inference. The blue expanses that look so authoritative are, in enormous stretches, educated guesses. The reason for this comes down to physics, and specifically to the behavior of 2 very different kinds of energy. The satellites that mapped every road and rooftop on land rely on light and radar, and neither penetrate seawater to any useful depth. A few tens of meters down, sunlight is gone. The radar pulses that can measure the height of a mountain from orbit simply bounce off the sea surface and never reach the bottom. Water, which makes the ocean possible, is also what makes the ocean opaque to almost every tool we have built for seeing at a distance. To map the floor of the sea, you cannot look down from above. You have to go there, or send something that can, and you have to use sound. This is where the apparent contradiction of the global map begins to dissolve. The smooth seafloor terrain visible in consumer mapping applications is largely derived not from sonar, but from satellite altimetry, a clever technique that measures tiny variations in the height of the sea surface itself. A massive underwater mountain has enough gravity to pull a slight mound of water above it, a bulge of perhaps a meter or 2 spread across many kilometers, imperceptible to any human but detectable from orbit. From these gentle swells and depressions in the sea's surface, scientists infer the shape of the ground far below. It is an ingenious method and a genuine achievement, but its resolution is coarse. It can reveal a seamount rising a kilometer from the abyssal plain. It cannot reveal a shipwreck, a rock outcrop the size of a building, or a channel carved by an ancient river. Anything smaller than roughly a kilometer or 2 across effectively vanishes. The global map, in other words, is a map of the ocean's large bones, not its features. The blank spaces are not marked as blank. They are simply filled in smoothly, and we mistake the smoothing for knowledge. So when a survey ship's sonar paints a distinct object on the seabed, The accurate reaction is not that the map was wrong. The map was never that detailed to begin with. What the ship has done is switch from the blunt instrument of satellite gravity to the precise instrument of sound, and at that resolution, the world becomes crowded with things no one had ever recorded. This is the routine miracle of ocean survey work. Nearly every high-resolution expedition into unmapped water finds features that appear on no existing chart, because no existing chart had the resolution to hold them. The sound itself is worth understanding, because it explains both the power and the strange ambiguity of what the crew sees. The instrument towed behind the vessel, called a side-scan sonar, sends out fan-shaped pulses of sound to either side. Those pulses travel through the water, strike the seabed and whatever rests on it, and return as echoes. Hard surfaces like rock or metal reflect strongly and appear bright. Soft mud absorbs sound and appears dark. And crucially, anything standing up from the floor casts an acoustic shadow, a region behind it where the sound could not reach, which registers as a stretch of blackness. The operator reading the screen is not looking at a photograph. They are reading a landscape of brightness and shadow, interpreting height from the length of a shadow, the way you might judge the time of day from the shadow of a tree. It is a skill closer to that of a radiologist reading an X-ray than a passenger looking out a window. And like any interpretive skill, it leaves room for the mind to fill gaps with expectation. This is the point at which many stories go wrong, and it is worth being honest about it. A regular shape on a sonar screen invites the imagination. The human brain is relentless in its search for pattern and meaning, and a symmetrical smudge on the seabed will readily suggest a sunken vessel, a wall, a runway, a structure. The history of ocean exploration is littered with sonar targets that were confidently declared to be one thing and turned out to be another. Geological formations have been mistaken for wrecks. Natural rock arrangements have been read as ruins. In the deep sea, where no one can casually go to check, an ambiguous image can accumulate a mythology long before anyone confirms what it actually is. The discipline of the work lies precisely in resisting that first thrilling interpretation. Because the truth is that the seabed is full of regular shapes that owe nothing to human hands or to anything mysterious. Geology produces astonishing order. Undersea landslides leave blocky debris arranged in almost architectural rows. Methane, seeping up through sediment, builds hard carbonate pavements and mounds with surprisingly clean edges. Currents sculpt sand into long, evenly spaced ripples that, from the right angle, look unmistakably artificial. Ancient shorelines, drowned when the seas rose at the end of the last ice age, leave terraces and ridges that trace the outline of a coast that human beings once walked. When a sonar reveals something that isn't on any map, the overwhelmingly likely explanation is not the extraordinary one. It is that the Earth, working over spans of time we struggle to imagine, is simply better at geometry than we tend to assume. And yet, the phrase carries a genuine truth alongside its temptation, because sometimes what the sonar finds really is a record of human presence, and those findings reframe the mystery rather than resolving it into legend. Consider what actually lies scattered across the world's continental shelves. During the last ice age, when so much water was locked into glaciers that sea levels stood well over 100 meters lower than today, vast areas that are now seabed were dry, habitable land. The shallow floor of the North Sea was once a low plain of rivers, marshes, and forests where people hunted and lived, a lost country that researchers named Doggerland. When the ice melted and the water returned, that world was not destroyed so much as submerged, its riverbeds and settlement sites preserved beneath the waves. A sonar passing over the right stretch of that drowned plain can trace the channel of a river that has not flowed for 8,000 years. A feature that is genuinely on no map because the landscape it belonged to predates the very idea of maps. The unmapped thing, in that case, is not fantasy. It is memory, held in the shape of the ground.
Hold fast!
The same is
She's
true of the more
breaking
recent
apart.
human record. The seabed holds an estimated 3 million shipwrecks, the overwhelming majority undiscovered and unrecorded. Every one of them was, at the moment of its loss, a small catastrophe, and most were never precisely located. A survey ship crossing an ordinary patch of ocean has a real chance of passing over one of these, and when the sonar catches the outline of a hull or the shadow of a mast lying on its side, the crew is looking at something that is, quite literally, on no chart. This is the ordinary way that history is now recovered, not through legend or treasure maps, but through the patient, systematic sweeping of the floor with a sound, one 4-knot pass at a time.